Hello everybody, it's Mr. Zabo. Today, this video is going to talk about sets. We're going to write and identify sets, we're going to write and identify subsets, and find complements of sets. The first thing I need you guys to do is practice. This is set notation. These are braces, and when we write braces, we are indicating that we're working with a set. I want you guys to trace the dashed lines. That's what it should look like. Then try to draw three of your own on your own separately. Now, I tried to draw them as good as I can quickly, and then just sloppy quickly. I'm not looking for perfection here. If I can get you guys to get them to look even just like this, that's good. The only thing I'm making sure I don't see, I don't want them to look like parentheses, and I don't want them to look like brackets. Those, obviously, we just finished sections talking about interval notation, represent different things. It's a different symbol, it's a different sign, and it matters. Also, don't make it look like arrows. Different symbols, different signs, they mean different things. So go ahead and pause if you haven't already done this, and try these. Okay, so with all of that said, there are two different ways that we are going to talk about writing sets. First is roster form, and the second is called set builder notation. This is one that's going to be pretty important. We're going to use this actually most often in this class. You'll use it most often in your Algebra 2 class and beyond as well. Roster form is when we just list all of the elements in the set within the braces. So every single element that's inside of a set, you put into the braces. So the examples of the set for multiples of 2 would be 2, 4, 6, 8, and then we would put this ... to represent that pattern would continue forever. That is all inside the braces, and our elements are all separated by a comma. Set builder notation is where we use these braces and then this other symbol. So what I've tried to write here is exactly how you would say this. You open the brace, it's saying the set of. And then it's the set of what? That's the first thing, the first part of the next section here is saying the set of what? All x values, since we put the variable x. This vertical line is a shorthand way of writing the words such that. So it's saying the set of all x values such that, and then what? X is a multiple of 2, and your braces. Set builder notation. I don't have to list every single one of these sets, or every single element in the set. So let's get a little bit of practice with that. So I'm going to write A is the set of all whole numbers less than 4 using each form. So first I'll write it in roster form. This is just listing. So I'm going to put capital A equals. That's naming the set capital A, and it's equal to. I need the brace. Open the brace. Roster form. So now I'm just going to list every single element. It's a whole number. Those are our 0, 1, 2, 3, 4, 5, 6. They are positive counting numbers in 0. And it's less than 4, so we'll start at 0, and then 1, 2, 3. 4 is not included in this set, because it is not less than 4. Close my brace. That's roster form. Now, if I was going to use set notation, or set builder notation, I start it the same way, but now I'm going to write it a little bit different. I'm going to say the set of all x values such that, and now I'm going to list what it is I'm building the set of. The set of all x values such that x is a whole number less than 4. So just describe exactly what you're working with. Here it's the specific elements, here it's a description of the elements. Let's do one more together. N is the set of even natural numbers that are less than or equal to 12. So N is the set. Natural numbers do not include 0, 1, 2, 3, 4, 5, but I just want the even ones. So it's 2, and 4, and 6, 8, 10, 12, and I stop. It's equal to 12, so 12 is a part of it. I close the set notation. To do the same thing in set builder notation, N is the set of all x such that x is an even natural number less than or equal to. So again, if you want to start using inequality notation at that point, you can. 12, close your set. Alright, so there are two more examples here. I want you guys to try this one on your own, and then we'll come back together to do this last example. So pause, try this one, and then we'll move forward. Alright, so in roster form we list each element. The integers are my counting numbers, both positive and negative. We want it greater than -1 and less than 4, so that's not inclusive. So that's 0, 1, 2, and 3. And here I'm describing that it's an integer and less than -1 or greater than -1 less than 4 is a compound inequality. It is important that you state that it's an integer. If all you write is the compound inequality, you're stating that it doesn't have to be an integer. So 0.5 is not an integer, but it's in between -1 and 4. So you do need both of those parts for this to be accurate. Alright, so now let's get to the more concrete examples back to this chapter. So if we solve this, we want to write our solution using set notation. And that's a lot of times where we come up with set notation. In order to do this, we'll go through the process of solving. And through the magic of video, we do it quickly. And what we see here is, I can't write every single element of this set. It's not specifically to the integers, or to the natural numbers, or the whole numbers. So -2 is a solution, so is -1, so is 0, so is 1, so is 2, but so is 0.5 and 0.6 and 0.7 and 0.8. It's basically, if I called this set S as my solution, my set would include -2 and all these decimals and stuff in between. It's impossible to write this in roster form, which is why we have set builder notation. Set builder notation makes this easier. It's going to be the set of all x values such that x is greater than or equal to -2, and your set. That's it. I don't have to describe anything in more detail. I can just write this in set builder notation.